form. Part A, we're going to do 9 over the square root of 3. So we know that we do not need to have that square root left in our denominator. How can we find an equivalent fraction that will have how can we eliminate a square root from this denominator without changing the original value of the fraction? Well, if we just wanted to concentrate on getting rid of the square root, what can I multiply the square root of 3 by so that it's no longer a square root? In order to eliminate a square root, I need to multiply it by itself. If I were to multiply the square root of 3 times the square root of 3, then what would that give me? So I'm just going to change my color so that it's not all running together for you at home. I'm going to multiply square root 3 over square root 3. All right, why did I do the top and the bottom? I'm doing the denominator by the square root of 3 because I know square root of 3 times square root of 3 is the square root of 3 squared. And or the square root of 9, the square root of 9 gives me 3. Why did I multiply the numerator by the square root of 3? Well, I'm multiplying this fraction by a value, and I cannot change the original value. So if I multiply the same thing over itself, I'm really just multiplying it by 1. So that way that allows me to make whatever adjustments need to be made to my denominator without changing the original value of the problem. So this will give us an equivalent fraction. Multiplying across the top now, I've got 9 times the square root of 3. Let me get that in my black pen now. My denominator, square root of 3 times the square root of 3, is the square root of 9, which is 3. Okay? This can be simplified. The 9 on the outside and the 3 in the denominator need to be reduced. So it becomes 3 times the square root of 3 for my answer. Let's look at part B. We've got the square root of 3y over 20. I'm going to start this time by using my quotient rule for radicals, which tells me that I can break this apart into 2 separate radicals. It's going to be square root 3y over the square root of 20. Now I've got square root of 20 in my denominator. I need to eliminate this. So what can I multiply the top and the bottom of my fraction by to eliminate this square root in the denominator? Let's do square root of 20. So we're going to multiply the top of the square root of 20, multiply the bottom of the square root of 20. Multiplying straight across the top, I can combine these into one radical, giving me the square root of 3 times 20 is 60, so 60y, over the square root of 20 times the square root of 20 is the square root of 20 squared, and my square and my square root cancel each other out. So I've just got 20 in my denominator. I do need to make sure that this is in simplest form. So to put this in the simplest form, I first need to think about what can I do to simplify this radical in the numerator. The square root of, is there a way that I can write 60 so that it includes a perfect square? What do I mean by a perfect square? Well, just to make sure everybody's on the same page, perfect squares will be numbers like 1, 4, 9, 16, 25, 36. You could probably continue this list on your own. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. Is there a way that I can write 60 as one of these numbers times something? Well, yes, there is. 60 is 4 times 15. So let's write that as the square root of 4 times 15. So we have square root of 4 times 15y over 20. Hopefully you see how this helps me. The square root of 4, I can do that, and that just gives me 2. So I've got 2 times the square root of 15y over 20. I do need to simplify my fraction. The 2 and the 20 have a common factor of 2, so we can simplify this, and I will go ahead and note at this point, make sure that you understand that you cannot simplify anything inside a radical with a number on the outside of the radical. So you cannot reduce 15 with 20 because 15 is inside the square root. But the 2 and the 20 we do need to simplify. 2 goes into 20 10 times, so we can write this as the square root of 15y over 10. And that's our answer. For example 8, we're asked to perform the indicated operations and simplify your answer. So we've got square root 8 plus square root 20 minus the square root of 12. All right, in order for us to be able to combine any of these radicals, it's very important that we have like terms. How do we create like terms from square roots? First, you'll notice that these are all square roots. The index on each of these, you don't see it written, but it's a 2. So that's important to notice. We also need to see if we can possibly get the inside of our radicals to match. If we can, then we might be able to combine them into a common radical or a single radical. If we cannot get the same numbers on the inside of the radicals, then we won't be able to combine them. So the first thing we need to do is try to simplify each of these radicals. Looking at the 8, we've got the square root of 8. All right, so can we write 8 as a perfect square times anything? So again, you'll remember the numbers that we wrote, listed out the perfect squares. Can any of these be used as a factor of 8? Yes, 4. So you can write this as the square root of 4 times 2. All right, and then we'll be in the next step, we can break this apart by simply taking the square root of 4, and then we'll have the 2 left inside the square root. Square root of 20 can be written as the square root of, again, 4 times 5. And then the square root of 12 also has a factor of 4, so it can be written as 4 times 3. So this does allow us to pull that 4 out of each of these radicals. The square root of 4 is 2, so we're going to have 2 times the square root of the 2 that's still inside. Square root of 4 is 2 times the square root of 5 minus the square root of 4 is 2, and that leaves the 3 on the inside of the square root. Now the question is, can any of these be combined any further? The answer is no. Again, we cannot combine these any further because we have different numbers inside each of these radicals. In order for us to combine these, everything would have to be identical except possibly for the number in front of the radical. So if we had all 2's inside the radicals but different numbers on the outside, then we could combine them. Here we cannot, so this is as far as we can take it. Part B, for example 8, we're asked to perform the indicated operations and simplify our answer for negative 3 square root 2 times 4 square root 6. So it's important to distinguish between numbers that you see on the inside of the radical versus numbers on the outside of the radical. Using the commutative property for multiplication, we can rearrange these if you want to. And you can say that this is negative 3 times 4, which we know is negative 12. And then the square root of 2 times the square root of 6 can be combined as the square root of, again, 2 times 6 is 12. Can we take this any further? We want to think about what we can do with our 12 on the inside of the radical. 12, as we saw in the previous example, can be written as 4 times 3. So we've got negative 12 times the square root of 4 times 3. This helps us, again, because 4 was a perfect square. So we can go ahead and say that this is negative 12 times the square root of 4 is 2. So multiply 2. And then the 3 has to stay inside the square root because it is not a perfect square. So we end up with an answer of negative 24 times the square root of 3. And that's as far as we can go with that one. Okay, so we're going to take a break from what we've been doing so far, and we're going to take a moment to talk about something called conjugates. Conjugates are binomials, meaning it's two terms. They look identical, but the sign in the middle is always different. So, for example, let's say I wanted to multiply the quantity 3x plus 5 times 3x minus 5. You know from algebra from high school that when you're multiplying binomials, a lot of times you might think of doing the FOIL method, the first, outer, inner, last. So we're going to multiply 3x times 3x. That gives us 9x squared. We're going to multiply the outer terms, 3x times negative 5. That gives me negative 15x, or minus 15x. Inside, I'm going to have plus 15x. And then multiplying the last two terms, it'll become minus 25. When we go to combine like terms, we see that these two middle terms are canceling each other out. They're giving us 0. Anytime that you multiply conjugates together, again, everything is identical except for the middle two terms. The middle signs, excuse me. Everything is identical except for the signs. The middle terms will always cancel each other out. So we're left with 9x squared minus 25. That's as far as we're going to take our answer. Okay, so let's look at another pair of conjugates. Again, these are just, everything is identical except for the sign. The two signs are different. So we're going to FOIL these. Square root 2 times square root 2, that's the square root of 4, which is also 2. Square root 2 times 5 on the outside gives us 5 square root 2. Multiplying the inside terms, we get minus 5 square root 2. And multiplying the last terms, we've got minus 25. Okay, now as we're going through this, let's pay attention to what happens to these radicals that we started with. When we take the square root of 4, that just gives us 2. What happens to my inner terms? Again, because these are conjugates, they're going to cancel each other out. So these are just 0. And we're left with minus 25. The 2 minus 25 gives me negative 23. So you see that the square roots that we had in the original problem are no longer part of the answer. Using these conjugates are going to be very useful in helping us rationalize some denominators. So for example 10, we're asked to simplify the expression by rationalizing the denominator. So again, that means that we need to find an equivalent fraction for this that no longer has a square root included in its denominator. We saw from the previous example that conjugates can help us eliminate radicals. So let's multiply the numerator and the denominator of this fraction by the conjugate of its denominator. So what is the conjugate of its denominator? That would be 3 plus square root 6. So we're going to multiply the top and the bottom by 3 plus square root 6. Because you are multiplying binomials, it's very important to include parentheses around each of these binomials, because we have to multiply every term here with every term here, and same down here. So we're going to distribute in the top. Square root of 3 times 3, that gives me 3 square root 3, plus square root of 3 times square root of 6, it's the square root of, and again the product for radicals tells me I can combine these into the same radical, so it's going to be 18, multiplying 3 and 6. In my denominator, 3 times 3 is 9. You can FOIL this out if you need to, but we know because these are conjugates, the middle terms will cancel out for us. So all we have to do is look at the square root of 6 and the square root of 6. Multiplying those together gives us 6. So minus 6. And then to simplify this, we've got, in the numerator, what can be done in the numerator to simplify? Think about your 18. You need to see if you can get anything out of that radical. If you think about factors of 18 that you might be able to use to help you, is there a perfect square that's included as a factor of 18? 18 would be 9 times 2. So you can say that this is the square root of 9 times 2. The denominator, 9 minus 6, gives me 3. All right, so now I have 3 square root 3. Some more space. Okay, so we've got 3 square root 3 plus the square root of 9 is 3, and then 2 stays inside the square root, all over 3. This is not simplified. Excuse me. Each of these factors has a each of these terms has a common factor of 3, so we need to simplify this further. Because the denominator now just has a single number or a single term, we can break this apart into 2 pieces, and we can say that this is 3 square root 3 over 3 plus 3 square root 2 over 3. Writing it this way, we can see that these 3's are going to cancel here and here. So we've got square root 3 plus square root 2. That is our final answer for that problem. Okay, so that completes our discussion for section B2. We will be practicing these more when you come back to class. Make sure that you ask questions as needed, and I'm always more than happy to do anything I can to help you. All right, I'll see you in class.